I use that as my basis. Okay, I don't know. I can't count. But in the Ising model, four quasiparticles like this is called a tetron. Tetra meaning four. 6 quasiparticles would give you a hexon. Hex meaning 6. And in a hexon, you have four dimensions. So you can use it to store 2 qubits if you wanted to. Actually, I think what the Microsoft people do is they only use, like, they're talking about using hexons, so 6 particles at a time. So they should have 2 qubits, but I think they talk about only using one of the 2 qubits for the data. The other qubit's like an insula. Yeah. Okay, so that's how we encode. Then how do we compute? What we compute is we, like, if I want to do a 1 qubit gate, I can mix these guys up to do something. If I want to do a 2 qubit gate, I have to mix these guys with these guys by braiding them around. And the problem is when we start like braiding this guy with this guy, you're gonna come up with a diagram that typically will have a 1 here. Just because, like, when you're mixing things up, there's no reason that this would stay a 0.
Yeah.
And so that's bad because it's outside of our space. It's not a qubit to qubit operation. So what you got to do is you got to come up with. It won't just be one braid. To do interesting qubit operations, you got to do complicated braids. And the complicated sequence has to be in such a way that this stuff will all cancel out at the end of the day, and so you'll have a 0 here. So you don't leak out of the qubit space.
And the braids translate to like experimental sort of, I guess, changes in current or something, or.
I don't know. I mean, you could just imagine we have these scanning electron microscopes. And, it's not really important.
Okay.
But, right, and so that's what's happening in these, like in these